Hey y'all, I'm Ralper, and welcome to Skyrim Scripting. This is part of the series focusing on teaching you how to create SKSE or Skyrim Script Extender plugins in C++. Now this episode goes out to everyone who, when given a sample project, just can't help themselves. You see all these files, and you gotta know what every single one is. You can't just, tell you, hey, don't worry about it, focus on just this little bit of C++. The rest of it doesn't matter. No, not you. You're a different type of person. You need to understand every single one of these files. Well, this episode is for you. I'm going to give a tour of all the files in the Hello World template so you understand them. If some of this goes over your head, don't worry about it. You can always revisit this. Maybe it'll make more sense to you later. So you can focus on just the files that are interesting to you, or just listen and get an overall sense. So maybe things are a little bit less, unknown and magical. So what we're going to do is we're going to just simply download this template. I'm going to use GitHub Desktop, which I love to use because look how fast it was to just open this up. I'm going to open this up in Visual Studio Code. If you want to learn how to set up Visual Studio Code for C++, I'll have an episode focused on that. Okay, normally it might ask me if I want my debug or release setting, but I've done that before on this computer. So it's just going to go ahead and run its CMake settings automatically, but we don't care about that. We're going to look at the files, top to the bottom. VS Code. There is one file in VS Code's folder called launch.json. It has a little, why is it angry about that? Missing property. Oh, cool. I guess I need to tweak this file, but I promise you it works. This is the C++ debugger configuration, and it sets it up so that when the game is running, you can just hit F5. Come on. And it will ask you what process to attach to. So I could attach to the Visual Studio Code process, but normally you would type in Skyrim. Check out I know that's wrong because we're not actually selecting a process, we're just demonstrating it. Check out the debugging episode for a demonstration on how to do debugging in Visual Studio Code, and CLine. So that is the launch.json in the Visual Studio Code folder. There is a Clang format file. Now, when I can, I have added some comments to some of these. I haven't done all of the files yet, but this one is totally optional. It makes it so that when I'm writing my C++ code for these templates, whenever I hit Control S to save the file, it automatically will format that file using Clang format. So I can specify, for example, if there's more than 120 characters on a single line, it'll add new lines to the best of its ability so that it doesn't end up being a super duper long line. All sorts of things like that. It doesn't use tabs, it uses spaces, it uses 4 spaces to represent tabs, yada, 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 yada. I do this so that there's consistency across all the templates. So there's a git ignore file, which should be familiar to you if you've used Git before. I should actually add some more things to this and add some comments to it. But basically this will ignore the Visual Studio and CLine kind of profile directories that those IDs create, just to put a bunch of nasty files in there to keep track of information about how you have your project set up. It's not nasty, it's good stuff, but I don't want it in my Git. We don't want the build folder, of course, that has the actual gigs and gigs and gigs of actual built. The DLL itself is really small, but all the files that get created to build your teeny little 500 kilobyte DLL, it's generally a couple gigs worth of stuff that get installed into your build folder. CMake lists is kind of where it's at. If you're interested in this, I'm going to do an episode on CMake. It's going to be kind of a comprehensive tutorial. I'll see if I can also do a kind of shorter CMake episode just with the essentials. But to start with, I want to pretty soon make a big old tutorial on everything about CMake. What you need to care about in this file is, 1, it has the name of your project. So whenever you clone one of these templates, probably the very first thing you want to do is you want to go to cmakelists.txt. So go ahead and open up this and go to project and change this to something like coolest project ever. And you'll notice that when I hit Control S, it's going to automatically pop open this window and it runs a CMake configure. It will reconfigure the project. So actually, if I go to my mod organizer 2, for example, right now, I've set this up like I did in the Hello World episode. If I just run F7 to build this project, or I could just do the build button that's normally right here where it says stop, we should get a coolest project ever showing up in our mod organizer 2 because we changed the name of it. Let's refresh. It says coolest project ever. And if we open that up, we'll see that it deployed an SKSE plugin and the DLL itself is called coolest project ever. There's a PDB file, which is quite big. It's 21 megs versus the 2 meg DLL, which actually itself is quite big. If you compile this as a release version, it'll be like smaller than 500 kilobytes. These have extra debug information, and you should use them when running locally, but normally you're going to want to switch to release mode when you share it with others. Okay. And it says you do not need to edit anything under here. If you remember from, or actually more specifically, if you read the Hello World README, it may have changed by the time you're watching it. By the time of recording, it looks like this. And there's a project setup section where it says you can set your Skyrim folder or Skyrim mods folder environment variables. And those are the ways that the project knows whether to put your built DLL into your Skyrim data folder directly or into a mods folder if you're using a mod manager, because those are going to be the two places you're basically going to want to put that file so that it actually works. And these environment variables, I didn't, for this, the basic templates, I'm doing my best to not hide any functionality. I've got a thing called a starter kit, which may or may not still exist at the time that you're working on it, watching this, where I'm trying to simplify the projects for myself. But for these files, I don't want to hide any of the logic from you. So if you read this, it says, if there's a Skyrim folder and it has a data folder, set the output folder to the data folder. If there's a Skyrim mods environment variable and it exists, then make the output folder the mods folder / the name of the project. And that's how you end up with what we just had, where we had a mods folder here with the same name as the project. Then it sets up the project. And then if an output folder has been defined, and of course, there's a bit here where you could uncomment this. These files use the hash mark for comments. You could set the output to whatever you want it to be for this project. And then if there is an output folder that has been defined, either A, the Skyrim folder environment variable was detected, or the Skyrim mods folder environment variable was detected, or if you uncommented this and set it to yourself, then we will print out this little line that says SKSE plugin output folder. If I Control S, we should be able to see that because Control S runs the CMake configure. And we can see it prints it out right there, SKSE plugin output folder. It's going to put it in coolest project ever, SKSE plugins. There's some inconsistent slashes, doesn't matter at all. And what it does is it will make the folder and it will copy your DLL there, which is a bunch of things that may look complicated, but it's fine. It's not once you learn CMake. Just in your DLL folder, it takes your the target, which is your DLL, your main SKSE plugin project, and it puts it there. And if you ran this in debug mode, then it will also put the PDB file there, which is for debugging symbols. Let's go back to our file browser. The only other thing for CMake, VCPKG is related to CMake, but for CMake is this presets file. So I tried to keep this as short and sweet as possible. It's 34 lines at the moment. If I hit Control S, it might it formats it. I turned off my formatter whenever I save this generally so that it stays shorter. I might change that. But all it does is whenever you run the CMake build, whenever you hit F7 in Visual Studio or in Visual Studio Code, or hit this build button or build all in Visual Studio, or the little hammer in C-Line, whatever you do to build your project, what it's going to do is it's going to run the Microsoft Visual Studio MSVC compiler. That is cl.exe is the actual executable. Don't just try and run it yourself in a terminal. You have to set up this weird environment to run it. You would want to use the developer command prompt for Visual Studio 2022. But so this just sets some arguments that get passed to it. This is a very common argument. These are some other ones that are helpful for the common lib and just in general, that's like Unicode, etc. This is a line that tells CMake that it is using Visual VC package. You may remember from previous episodes that when you install VC package, you clone the repository or download it as a zip, you run Bootstrap, and then you set the VC root environment variable to this path. Well, guess what? You just found the place where we actually read that environment variable. VC package root. There's a CMake integration file that this sets up CMake to use, so that CMake integrates with VC package, and when the CMake project gets configured, that's what happens automatically whenever you open up this folder in Visual Studio or Visual Studio Code or CLine for that matter, or if you save the clist.txt CMake list. Anyway, here's triplet, don't worry about it. Overlay triplets, don't worry about it. Runtime library, don't worry about it. This is something I have in here by default, so it supports ClangD, which I will have a Visual Studio Code episode on how to set this up. It gives you better auto completion and things like that. So that's kind of it. And then down here, there's a debug and release kind of setup. This is just required so that you can say, hey, please make my CMake build debug versus release. And that's what allows this right here, come on out of the way, to show up. That's what sets this up. Debug and release, those come from right here, from the CMake presets. You don't need a CMake presets. You could configure one in CLine via the UI. It should be there. I guess if we're going top down, next are actually code of conduct and license, which are interesting choices of mine to include. If you go to the Hello World project and see the setup your repository section, it says that if you clone the template and put it on GitHub, you should go into the license and change the year to change the license to be licensed to you, and change the code of conduct to have your own information. It's good to have a code of conduct, and GitHub will show your code of conduct in the project sidebar. If you want to know more about licensing, here's some stuff about licensing. I should update this to point out that by default, the license is MIT. MIT is the most popular license by far used in our community, which is why it defaults to MIT. I'm actually updating my personal projects to use something a little bit more permissive so that you don't have to attribute any of my code to y'all, to me. So it's MIT license and code of conduct. If you click on it, it'll take you directly to the code of conduct or license. So in those files, of course, you could just delete them if you don't want your project to have these. It's totally fine. But you should be able to scroll down and see your contact information here. That will allow people, if they're being harassed on your project in the GitHub issues or something like that, if they feel like they're being bullied, they could reach out to you. Keeping the internet a safer place. And then license here is the MIT license, and I can update this to 2023. I'll do that, and I'll update the main page to point out that it's MIT. There are more permissive licenses. There's more restrictive licenses, which I personally super duper don't recommend, but if you're interested, you can go to the licensing and repository information page from GitHub, or choosing an open source license is a lovely site. It's choosealicense.com, and it'll walk you through some of its recommended licenses. If you want to keep things very simple and permissive, the MIT license is short and to the point. It lets people do almost anything they want with your project, like making and distributing closed source versions, which I highly recommend. Personally, please don't use a GPL license unless you have a good reason to and you understand why. Apache 2 is a similar one to MIT. It's very nice, but has patent protection. Just all delicious. Top bottom, precompile header.h. You don't really need to know that this exists. If we were to go back to CMake lists.txt, we would see that These are the 4 lines that set up a Common Lib SSE NG, in this case, SKSE plugin. So what it does first is it looks up Common Lib SSE as a dependency. Then it uses a helper provided by the Common Lib NG CMake kind of helpers called add Common Lib SSE plugin. And that's where you add your plugin CPP file. It tells it to use C++ standard 23 required. And then it has this target precompile header thing. Basically, it'll add this to the top of every file, kind of essentially when it does things. And the way that Common Lib is currently set up, I haven't been able to get it to work without a precompile header. This is the smallest precompile header I've been able to find that works. Basically, it'll blow up if these aren't here. All of the files in Common Lib tend to assume that these have been included, and so it's just a thing that you need. Just a thing that you need. Just a thing that you need. Plugin.cpp is where it gets fun, although we're still saving the best for last, arguably, with VCPKG. Plugin.cpp is your plugin. It's your C++ code. This is where all the fun goes. Good? Good. And of course, you can always take some of this code. You can cut it and put it into a .h header file so that you can have a bunch of header files and include stuff in your CPP. We'll eventually do that. We're going to touch on that in the logging episode a little bit. But I'm intentionally trying to keep all of our plugins that we use throughout the series really simple so you can keep everything in one file. Once you learn C++ better, you'll become more comfortable adding multiple files and adding directories and changing your directory layout. There's a reason why this is just a folder with a bunch of files and not a bunch of subdirectories. I'm trying to keep this as simple as possible for you. Here, of course, is the README, and that is the README. Here is the VCPKG configuration. This is interesting. So VCPKG is the package manager that we use to pull down Common Lib SSE and all of its dependencies. So Common Lib SSE at the time of recording, we're pulling down from the color glass VCPKG repository, which is basically Charm Variant's repository hosted on GitLab. So if we go here to GitLab, see that 1 month ago, the most recent version of Common Lib NG was released. I can see that from, I'm just guessing, from 1 month ago. These are some fixes. Here's a bunch of things, a bunch of documentation about this. But basically, Git repositories or projects, every time you add a new save to it or commit, those commits have identifiers. Instead of the first commit being called 1 and the second save being called 2 and then 3 and 4 and 5, they use a SHA hash. So you end up with something like this instead. You end up with, this is actually the latest version. It allows people to, it allows for multiple contributors to work on one project more effectively. If it just, your save was 2 and then someone else worked on the same project and they had saved 2 and you tried to push the same project, it would blow up. That's one of the reasons why we use these. This is the number, basically. And so in our project, we'll see that this, it looks like, is the most recent baseline. It looks like I could update this, actually. So whenever we install Common Lib, it's going to point to whatever the version of Common Lib being distributed by VCPKG was at this baseline. If I go back then to Color Glass, and I'm just going to look at the commit history, we're using 6FB. Cool, 6FB is actually, it looks like the most recent, probably Common Lib. We'll have to see what this is. It looks like Nikita here may have added a other thing. Ooh, update and fix SKSE. So I'd have to see if we could dig in and I'll update mine. So basically I try and keep mine up to date to match Color Glass. If there's been some changes, you can always go and update this SHA right here by going to Color Glass, VCPKG repository at gitlab.com/colorglass/VCPKG-colorglass and just hit this little copy button. Boop. and now you've copied the latest version. We could go like this. Boop. If I hit Control Save, my CMake configure is actually going to run. Now, similarly, we keep track of the latest version of the actually Microsoft VC package. Microsoft's version of VC package that has everything hosted. Basically, you can make your own little mini GitHub projects that host your own libraries, but Microsoft has one that hosts libraries for everyone. They're called registries. And so if I wanted to keep this one up to date, what I would do is I would go to these commits or this commit right here, and I would grab this. And so this is the most recent Microsoft one. And so under Microsoft right here, I put that. Control S, it's also going to do it. And these are the ways that you keep things up to date. So this is actually really important to know if you want to update dependencies. If you're pulling some dependencies from Microsoft, you'll want to always update this. So it's called VC package configuration. It configures the registries versus vcpackage.json, the final file that we have here. This one actually specifies the dependencies themselves. So I might pull in, and there might be something called simple INI or something like that. I might use something for JSON, or I might use sockets. Might use whatever. These are your dependencies, and they will get pulled down automatically whenever I hit Control S, essentially. I think there's something called simple INI. So if I hit Control S, oops, my computer started making sounds, so maybe it's doing all kinds of stuff. Oh, another thing is already configuring it. Oh god, I updated it, so it might be rebuilding my common lib version. Oh no! Oh god, I want to close Visual Studio, but even if I close Visual Studio, it's probably running CMake in the background. Should I wait for it to finish? This is what happens when you update to new versions of Common Lib. Get a bunch of compilation running. I'm gonna wait for this to finish. Well, the fan stopped spinning in my computer, so I believe I've now updated to the latest version of Common Lib. So just heads up, that's what happens. So that is a general walkthrough of all these files. I hope for anyone who needs to know and needs to understand what every single one of these files does, I hope this gave you what you were looking for. If you've got more questions, I guess post them as an issue, or better yet, find me on Discord, and we can update these templates together to make them even more easy to understand for newcomers. All right, that's it for this episode. Go ahead and check out that playlist to see what is next and continue your SKSE learning journey. And as always, happy modding. All right, happy modding, everyone.